5. Another question. 2 into 6 into 10 into 14 into and so on up to 482. 482. If we keep on counting it, it will be a very long process. So we will go step by step. 2, 6, 10, 14 and so on up to 482. Step number 1. Once you understand the flow chart, it is very easy. Tn equivalent to a plus n minus 1 into d. A plus n minus 1 into d. So Tn is, first term it is 2. N minus 1. Difference it is 4. So this will be 4n minus 2. Tn can be given as 4n minus 2. 4n minus 2. N can start taking from 1. So n, if it can it take 121. 484 minus 2. 482. 1 less than or equivalent to n less than or equivalent to 121. So n value can move from 1 to 121. I hope the idea it is clear. Very, very good question, sir. Step number 2. Step number 2. 4n minus 2. It can take either a multiples of 5 or step number 3. Step number 3. It can take a multiples of 125. 25b. Step number 4. It can take a multiples of 125. 4n minus 2 equivalent to 125c. Step number 5. It can take 5 power 4. 5 power 4 is 625. 4n minus 2 equivalent to 625d. These is not possible. These are not possible. Highest value is still 482. Now slowly, step by step, counting, be very careful, sir. So these 4n equivalent to 5a plus 2. 4n equivalent to 4a plus a plus 2. A plus 2. These divisible by 4. These divisible by 4. A plus 2 should be divisible by 4. A minimum value, it should be 2. 5 2s are 10. So this will be 10 plus LCM of 4 comma 5 into k. 10 plus LCM of 4 comma 5 into k. K value 0, it is 10. K value 1, it is 30. K value 2, it is 50. Now these k value, how many it can take? It can take from 0 to, how many it can take? 20. I require 482. 20 24s are 480 plus 10. 480 plus 10, it is 490. So it will be from 0 to 23. 20 into 23, 460. 460 plus 10 is 470. K value 24. 20 into 24, 480 plus 10, it is 490. 0 to 23. How many multiples of 5 I got? I got 24. Are you all with me? So just to take the upper limit. This will be 4n equivalent to 25b plus 2. 25b plus 2. 4n equivalent to 24b plus b plus 2. 24b plus b plus 2. 4n it is divisible by 4. It is also divisible by 4. So b minimum has to be 2. If b minimum it is 2. 50. 50 plus LCM of 4 comma 25 into k. 4 comma 25 into k. K value can be 0. It is 100. K will be till 3. 100 3s are 300. 300 plus 50. 350. 400 plus 50. 450. K value can take 4. 0 to 4. There are 5. K is 4. 100 4s are 400 plus 50. 450. K value 5. 500 plus 5. 550. It is exceeding 482. I hope the idea it is clear. Slowly we have to do. It is not a difficult question. Just finding the nth term and equating with multiples of 5. That's all. 4n equivalent to 125c plus 2. 4n equivalent to 124c plus c plus 2. 4n, it is a multiple of 4. Multiple of 4. C minimum, it will be 2. If C minimum, if it is 2, this will be 250 plus LCM of 4 comma 125 into k. So k can take only 0, which is 250. So here 1 value, here 5 values, here 24 values. What is the number of trailing zeros for this question? Answer is 30. Very, very good question. This kind of questions you will struggle it, but it's very easy if you understand the flow chart. First, step number 1 is find out the nth term. Power of 5s are less than power of 2. Equate it with a multiple of 5. Every power of highest power of 5 is also a 25 contains 5. So take the multiple powers of 5. 5a, 5 square b, 5 cube c, 5 power 4, it is 625, but the upper limit is still 482. Very, very important question. Kindly, after the class is over, all the enrolled students revisit this question again. Take time to understand what is happening at each and every step. First, I did all the 5 multiples. Suppose if it is there, 5, 10, 15, 25 till 125. First I wrote all the multiples powers of 5. Then I wrote all the powers of 25. Then I wrote all the powers of 125. There will be extra powers of 5 that you will get in 25 and 125, that I wrote it in step number 2 and 3. Very, very important CAT model question. Please put a star mark and you can try to solve it. It's a take-home question. Try to do it on your own. 1 into 4 into 7 into 10 and so on up to 991. A practice question for you. In case if you want another practice question, 2 into 7 into 12 into 17 and so on up to 57. Find the number of trailing zeros. Find the number of trailing zeros. Find the number of trailing zeros. Try to solve this question. Take it as a take-home problem. We have done 2 examples. Do another 2 examples. This concept will be very, very clear to you. This concept will be very clear to you. I hope the idea it is clear. Idea it is clear. Which are the questions which are pending? This model, AP model also we covered. Then 2 into 5 into 8. Then factorial addition, factorial subtraction, factorial division, factorial multiplication, and without factorial. Let us solve this model. Question, please write down, sir. Find the number of trailing zeros. Find the number of trailing zeros. Same questions I am writing it here. 2 or 3 questions I will write down to the right side of the digital board. Find the number of trailing zeros. First question. 200 factorial plus 100 factorial. Number of trailing zeros is defined as the number of zeros at the end. 200 factorial can be written as 200 into 199 into 198 into and so on up to 100 factorial plus 100 factorial. 100 factorial I can take common. This will be 200 into 199 into 198 and so on up to 101 plus 1. Are you all with me? So this is a multiple of 5. 200 contains power of 5. 2 multiple of 5. To multiple of 5, I am adding 1. If I am adding 1 to a multiple of 5, this is not divisible by 5. It is not divisible by 5. Why? Because 200 into any number only, it is divisible by 5. Adding plus 1, that means it is of the form 5a plus 1. For factorial based problems, number of zeros at the end, it is always given by the highest power of 5. So 20 plus 4. Answer for this question is 24. Number of trailing zeros for 200 factorial plus 100 factorial. Answer it is 24. Even if the same question is like this, 200 factorial minus 100 factorial. So these is nothing but 100 factorial bracket. This will be 200, 199, 198 and so on up to 101 minus 1. These divisible by 5. 5 minus 1. These divisible by 5 minus 1. That means this number is not divisible by 5. Number in the bracket is not divisible by 5. For factorial, it is always the highest power of 5. So first question and the second question, answer remains the same. First question and the second question, answer remains the same. Third question, 200 factorial divided by 100 factorial. 200 factorial divided by 100 factorial. Now, for factorial based problems, number of trailing zeros is based on the highest power of 5. So this it will be 200, it will be 5 40s are, 5 8s are, 5 1s are. So I will get 5 power 49 here. It is 5 power 24 into k1 by k2. 49 minus 24. How many zeros will be there at the end? For 200 factorial by 100 factorial. For 200 factorial, number of trailing zeros is given by highest power of 10. Because it is factorial, it can be condensed to highest power of 5. 5 40s are, 5 8s are, 5 1s are. 5 power 49, 5 power 24. A power m by a power n is a power m minus n. It is 25. Question number D. What if it is multiplied 200 factorial into 100 factorial? 200 factorial into 100 factorial. It is factorial. I got 5 power 49 into k1. It is factorial. 5 power 24 into k2. K1 into k2 will give you other prime bases. 5 power 73 into k3. Number of zeros at the end. Number of zeros at the end, it is given by highest power of 5 for factorial. Answer for this question will be 73. Answer for this question will be 73. Idea clear? Factorials added, factorials subtracted, factorials divided, factorials multiplied, factorials multiplied. I hope the idea it is clear. The question can also be like this. Question can also be like this. Factorials, we will raise it power 200 factorial, power 100 factorial. F 100 factorial, power 200 factorial. Find the number of trailing zeros. The question can also be like this. Every variety of questions, it will be there in your paid video course. You don't need to refer any other book. Everything in detail I will discuss. So 5 power 200 factorial. 200, we got 5 power 49 into k1 power 100 factorial. So these 5 a power m power n, it is a power m into n. A power m into n. A power m into n. So it is 5 power 49 into 100 factorial into k1 power 100 factorial. Anyway, k1, even if I take 2 I will get, suppose if I write it as, this will be 197 into k2. 197 into 100 factorial, it will be greater. So what will be the answer? 49 into 100 factorial. Find the number of trailing zeros for these power 200 factorial, power 100 factorial. 5 power 49 into k1 power 100 factorial. A power m in power n is a bracket, it is a power m into n. So here it is 5 power 24 into, I will write down it here, 2 power 97 into k3 power 200 factorial. Am I right? Power. So this will be 5 power 24 into 200 factorial into 2 power 97 into 200 factorial into some k3. So this can be written as 5 power 24 into 200 factorial, 2 power 24 into 200 factorial into 2 power 73 into 200 factorial. So if I take the combination, I will get the answer 24 into 200 factorial. Power also we did it. Factorial's addition we did. Factorial subtraction we did. Factorial division we did. Factorial power factorial also we did it. Every variety of question, it should be there. I hope the idea it is clear. This answer is 49 into 100 factorial. This answer is 24 into 200 factorial. What is the next question? What if the factorials are not given? How to find the number of trailing zeros if the factorials are not given? Question is, n is 91 into 92 into and so on up to 100, let us take. We want the trailing zeros for n. We want the trailing zeros for n. Trailing zeros for n. How to get the trailing zeros? For factorial, it is the highest power of 5. So, multiply the numerator and denominator. Multiply the numerator and denominator by 1 to 90 in the numerator and denominator. 91 into 92 till 100 divided by 1 into 2 and so on up to 90. I hope the idea it is clear. So this numerator will become 100 factorial. This denominator will become 90 factorial. 2 factorials getting divided. Which process to use? Already we have seen. Which process to use? Already we have seen. 100 factorial will be 5 power 24 into k1. 90 will be 5 18s are 5 3s are 18 plus 3, 21. 5 power 21 into K2. So answer is number of trailing zeros for this question. If the factorial it is not present. If the factorial it is not present, how to do it? Divide the numerator and denominator and convert it into a factorial. Then apply the highest power of 5. A power m by a power n. It is given by a power m minus n. A power m by a power n. It is given by a power m minus n. 24 minus 21. Answer for this question is 3. I hope it is clear. Let me see if any other questions are pending. Factorial to factorial. Addition, subtraction, multiplication, division. The series is in arithmetic progression. Series is in arithmetic progression. 8 into 16. 8 into 16. 8 into 16. Now GP also we will take. Now how to find out the highest powers? So suppose if the question is like this. If the question is like this. 8 into 16 into 32 into 32 into 64 into 864 into 128. How to do it? These 8 into 1. These 8 into 2, 8 into 3, 8 into 4, and 8 into 4 it is. 8 into 8, 8 into 16. Anywhere power of 5 is there, power of 5 is not there, so answer is 0. To get the number of zeros at the end, we need the highest power of 2 and 5. Minimum 1 power of 2 and minimum 1 power of 5 should be there. So here 5 means it should have unit digit 5 or 0. Nothing is visible to me. So the answer is 0. Equality, I am sure each one of you have understood how